This is SpaceTime Series 27, Episode 77, for broadcast on the 26th of June, 2024. Coming up on SpaceTime, discovery of the earliest ever pair of merging black holes. Perseverance discovers weird popcorn-like rocks on Mars. And flares and echoes from the Milky Way's monster supermassive black hole. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the earliest known pair of quasars in the process of merging. The discovery, reported in the Astrophysical Journal Letters, represents the earliest known merger of a pair of supermassive black holes, occurring at the cosmic dawn, just 900 million years after the Big Bang, 13.8 billion years ago. The universe has been expanding ever since the Big Bang. Now, what this means is that the early universe was considerably smaller and galaxies were a lot closer together, providing more opportunity for them to interact and merge with each other. Galaxy mergers help fuel the formation of quasars, the extremely luminous galactic cores where materials falling into a central supermassive black hole, in the process emitting enormous amounts of energy, so bright they can be seen across the other side of the universe. So when looking back at the early universe, astronomers would expect to find lots of pairs of quasars in close proximity to each other as their host galaxies undergo mergers. However, up until now, there have been exactly none. Cosmic dawn spans the first 50 million to 1 billion years after the Big Bang. It's an important period in the evolution of the cosmos. During this period, the first stars and galaxies began to appear, filling the dark universe with light for the first time. And the arrival of the first stars and galaxies also kicked off a new era in the formation of the cosmos known as the epoch of reionization. The epoch of reionization was a period of cosmological transition. Beginning somewhere between 200 and 400 million years after the Big Bang, ultraviolet light from the very first stars and galaxies and quasars would have spread across the cosmos, interacting with the intergalactic medium and stripping the universe's primordial fog of hydrogen atoms of their electrons, a process known as ionization. The epoch of reionization was a critical epoch in the history of the universe, marking the end of the cosmic dark ages and seeding the large structures in the universe which we observe today. To understand the exact role that quasars played during the epoch of reionization, astronomers are interested in finding and studying quasars populating the early and distant universe. The study's lead author, Yoshiki Matsuoka from Aimi University, says the statistical properties of quasars in the epoch of reionization tell astronomers a lot about the progress and origin of the reionization, the formation of supermassive black holes, and the earliest evolution of quasar-host galaxies. So far, around 300 quasars have been discovered dating back to the epoch of reionization, but none of them have been found in pairs. That was until Matsuoka and colleagues were reviewing images taken by the Subaru telescope and noticed two very faint but extremely red sources next to each other. The team weren't sure that what they had sighted was in fact a pair of quasars. That's because distant quasar candidates are contaminated by numerous other sources, such as foreground stars and galaxies, and the effects of gravitational lensing. So to confirm these objects, the authors undertook follow-up spectroscopy using the Faint Object Camera and Spectrograph on the Subaru telescope and the Gemini Near-Infrared Spectrometer on the Gemini North telescope. The spectra, which breaks down the emitted light from a source into its component wavelengths, obtained with Gemini North, was crucial in characterizing the nature of the quasar pair and their host galaxies. They found the quasars were too faint to detect in near-infrared, even with one of the largest telescopes on Earth. They now believe that some of the light they detected in the optical wavelength range isn't actually coming from the quasars themselves, but from ongoing star formation taking place in their host galaxies. The authors also found that the two supermassive black holes generating the quasars are huge, each being at least 100 million times the mass of the Sun. This, coupled with the presence of a bridge of gas stretching between the two quasars, suggests that they and their host galaxies are indeed undergoing a major-scale merger. This is SpaceTime. Still to come, NASA's Mars Perseverance rover finds weird popcorn-like rocks on the red planet, and astronomers are studying flares and echoes from the largest black hole in our galaxy. All that and more still to come on SpaceTime. After months of driving, NASA's Mars Perseverance rover has finally arrived at its next target, a rock formation known as Bright Angel, where it's discovered oddly textured rocks unlike anything ever seen before. Mission managers now plan to drive the 6-wheeled car-sized rover up the slope in order to uncover the origins of this weird rock sequence, and also try to uncover the relationship with the margin unit, that's the rocks near the rim of Jezero crater. Having completed a survey of the intriguing and diverse boulders of Mount Washburn, the rover headed north, eventually parking just in front of an exposure of layered light-toned rock. This provided mission managers with their first close-up look at the rocks that make up the Bright Angel exposure. So Perseverance stopped to acquire images before driving west to a larger and more accessible outcrop where the rover will conduct detailed exploration. Geologists on the science team have been mesmerised by the strange textures of these light-toned rocks ever since Perseverance arrived at the base of the outcrop. The strange rocks are filled with sharp ridges that resemble the mineral veins found at the base of another rock outcrop known as the Fan. But there appears to be far more of them here. Some of the rocks are densely packed with small spheres described as popcorn-like in texture. Together, these features suggest that groundwater once flowed through these rocks. Next, Perseverance will gradually ascend up the rock exposure, taking measurements as it goes. Its abrasion tool will also be used to take a close-up look and acquire detailed chemical information about the rocks using instruments on the rover's arm. Once they have this data in hand, mission managers will decide whether or not they want to grab a sample. Once the exploration of Bright Angel is complete, Perseverance will drive south back across the Neretva Valleys and explore a site known as Serpentine Rapids. Perseverance landed on the red planet's Jezero crater in February 2021. The 45-kilometre-wide impact crater was once flooded with water. It contains a fan-shaped dried-up river delta filled with sediments deposited from further upstream. The lake in the crater deposited rich clays and was probably formed billions of years ago during a time when there was continual surface runoff. This report from NASA TV.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
Jezero crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
And in that report from NASA TV, we heard from Perseverance project scientist Ken Farley, Perseverance Deputy Project Scientist Katie Stack-Morgan, Perseverance Deputy Project Manager Matt Wallace, Perseverance Mobility Team member Farah Alabay, and Perseverance Chief Engineer Adam Stelzner. All are from NASA's Jet Propulsion Laboratory in Pasadena, California. This is Space Time. Still to come, astronomers uncover new information about the Milky Way galaxy's central supermassive black hole, and later in the science report, a new study shows that older patients tend to live longer if their GP is a female doctor. All that and more still to come on Space Time. Astronomers have uncovered new information about the Milky Way galaxy's central supermassive black hole, Sagittarius A star. The new findings have been presented at the 244th meeting of the American Astronomical Society, which was held on June the 11th. Sagittarius A star is, of course, the central black hole in our Milky Way galaxy. It's located some 27,000 light-years away and has some 4.3 million times the mass of our Sun. Black holes are notoriously difficult to study, in part because not even light can escape their immense gravity. Scientists typically infer their properties by observing their influence on space around them. Astronomers Grace Sanger-Johnson, Jack Uteg, and Shuo Zhang studied Sagittarius A star using decades of X-ray data from space-based telescopes. Sanger-Johnson analysed 10 years of data from the black hole looking at X-ray flares, discovering 9 previously undetected ones. These flares are dramatic bursts of high-energy light, providing unique opportunities to study the immediate environment around the black hole, a region typically invisible. The data being obtained from it and its flares are one of the only ways currently known to study physical environments around a black hole. Both flares and fireworks light up the darkness, helping scientists observe things they wouldn't normally be able to see. That's why astronomers want to know when and where these flares occur, so they can study the black hole's environment using that light. Sanger-Johnson meticulously sifted through a decade's worth of X-ray data collected between 2015 and 2024 using NASA's NuSTAR Nuclear Spectroscopic Telescope Array. Each of the 9 newly discovered flares provide invaluable data for understanding the black hole's environment and activities. While Sanger-Johnson was focused on the brilliant flares emanating from Sagittarius A star, co-author Uteg examined the black hole's activity using a technique akin to listening for echoes. He analysed almost 20 years' worth of data targeting a giant molecular cloud known as the Bridge, which is near the supermassive black hole. Unlike stars, these clouds of gas and dust in interstellar space don't generate their own X-rays. So, when X-ray telescopes began picking up photons in the Bridge, astronomers started hypothesizing as to the source. The brightness is most likely the delayed reflection of past X-ray outbursts from Sagittarius A star. Uteg first observed an increase in luminosity around 2008. Then, for the next 12 years, X-ray signals from the Bridge continued to increase until it hit a peak in brightness in 2020. This echo light from the black hole must have travelled for hundreds of years before it reached the molecular cloud. But it then had to travel another 27,000 years before reaching Earth. By analysing this X-ray echo, Uteg has started reconstructing a timeline of Sagittarius A star's past activity, offering new insights into what would have been impossible through direct observations alone. Uteg's analysis used data not just from NuSTAR, but also from the European Space Agency's X-ray Multi-Mirror or XMM Newton Space Telescope. One of the main reasons the astronomers care about this cloud getting brighter is that it lets them constrain how bright Sagittarius A star's outburst was in the past. Within these calculations, the authors determined that about 200 years ago, Sagittarius A star was about 5 orders of magnitude brighter in X-rays than what we're seeing today. It's the first time astronomers have been able to construct a 24-year-long variability count of brightness coming from the supermassive black hole. That's allowing them to peek into the past activity of the largest black hole in our galaxy. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study shows that more than 1 in 5 people who have been infected with COVID-19 wind up taking more than 3 months to recover. The findings, reported in the Journal of the American Medical Association, are based on a cohort of 4,708 American long COVID patients. They are asked 3 months after their infection if they felt recovered. About 22.5% of the participants said they hadn't fully recovered after 3 months, with women more likely to report long COVID, as well as people who were in poor health before the pandemic, especially those with heart disease. The authors say people who were infected during the Omicron era and people who were vaccinated before they were infected were more likely to report a shorter recovery time. The World Health Organization says over 7 million people have been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. However, the WHO estimates the true death toll is likely to be above 18 million, with more than 775 million confirmed cases globally. A new study of more than 700,000 American patients over the age of 65 has found that those with a female doctor were less likely to die or be readmitted to hospital compared to patients with a male doctor, and the effect was more pronounced for female patients. Of the 458,108 females and 318,819 male patients, 142,465, or 31.1%, and 97,500, or 30.6%, respectively, were treated by female physicians. For both male and female patients, length of stay, spending, proportion of intensive evaluation and management claims, and likelihood of discharge did not differ between male and female doctors. The findings, reported in the Annals of Internal Medicine, claim that although this type of study can't prove that having a female doctor caused an improved outcome, the difference could be due to male doctors underestimating the severity of illness in female patients, female doctors better communicating with female patients, and female patients being less likely to be embarrassed and uncomfortable during sensitive examinations and conversations if their doctor was female. Artificial intelligence large language models such as ChatGPT and Gemini often wind up lying, making up information, a problem computer techs call hallucinations. But now researchers think one solution may be using other large language models to detect these issues. A report in the journal Nature looked at a specific type of hallucination caused by a lack of knowledge and looked at the nuance of language and how responses can be expressed in different ways to try and work out how likely it was that the generated content was correct. In an accompanying News and Views article, an Australian expert warns that using a large language model to evaluate another large language model does seem circular and might end up being biased. But the authors believe that their method may help people understand when they should take care in relying on the responses of artificial intelligence. Microsoft's new Copilot Plus PCs have been released, and the experts say they will fundamentally change the world forever. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Yeah, so they've now gone on sale. These are the PCs with the Snapdragon chip inside, which is a souped-up version of the smartphone and tablet chip designed to run laptops and desktops. And these are the first ones that have what's known as 45 trillion operations per second, which is more than Microsoft's minimum of 40 trillion operations per second to be counted as Copilot Plus PC designated devices, where a lot of the AI workload for editing and changing and improving text and for doing image generation can be done on device, even if that device is offline. Now, there has been a couple of scandals surrounding these PCs. One, people who have already been reviewing them have noted that different machines come with different classes of this Qualcomm chip. Some are faster than others. Some will have faster single and multi-core speeds over the cheaper ones. And that's not such a big deal if you're just doing everyday work. But if you're intending on running heavy games or doing a lot of work, I mean, obviously, you're spending all this money, you want to make sure that you get a faster chip. And it can be difficult to know which chip is which. It's best to read the reviews. And the reviews have come out. And one example is the Asus VivoBook S 15-inch laptop. Now, this is a machine that in Australia sells for $2,699. I think it comes with 16 gig of RAM and a 1 terabyte SSD, but it doesn't have a touchscreen. And for some people, they're going to want to make sure that the laptop that they buy, one from Microsoft, for example, or one of the new Lenovo ones, does indeed have a touchscreen. So you've got to check to make sure that you're getting the best chip you can for the money. The other bit of a scandal that's emerged is that, at least at this initial stage, and obviously there will be updates, but the graphics performance for some of the 3D games is also causing a bit of a problem. Some games run just fine, others don't run, or they stutter or glitch. And so the 3D performance of these is not the same as you would get from a dedicated Intel or AMD powered laptop with a discrete graphics card, or in the case of an AMD with good graphics capabilities built in, because AMD generally has good internal graphics, although they can be outfitted with discrete NVIDIA cards as well. So if you're a gamer, you might not necessarily want to get one of these machines without reading various reviews. And the other side of the coin is that the Intel and AMD computers that will be designated as Copilot plus PC, with the Intel chips able to do 48 hops or trillion operations per second, and the AMD ones from 50 to 60, depending on which one you buy, they're not due till later in the year. And the other thing is that these are version 1. Even though the first Windows on ARM PCs came out in 2013 with the Windows RT device, which didn't run any x86 programs whatsoever, and then we had the Qualcomm 8C3 chips in 2018. There was the first, second, and third generation. They could run x86 programs, which were 32-bit, but not the 64-bit ones. That emulation came later. But a lot of people bought those, and then a week or two later they returned them and got an Intel version instead, or an AMD version. So even though these new machines are technically the third generation, they're really the first generation of these supercharged chips. And as with anything in life, you should be careful about buying version 1 as such of anything. So, clearly next year there'll be machines with 100 tops, I would imagine, of AI power. So if you're happy with your computer at the moment, you've got a good laptop giving you hours and hours of battery life, and it's doing everything you need, and you can download ChatGPT or use the Copilot that's already built into Windows 11 to do all the AI stuff you want. There's no particular need to race out. And these machines are not your $1,000 machines. They're around about, they're over $2,000. We're talking more the premium end of the market. So it's a new computer. The initial reviews are good. People are impressed. They're running fast and everything. But, I would consider waiting to see some more reviews, waiting to see what comes out towards the end of the year with new models from Intel and AMD and how they compare. And obviously, as we get closer to Christmas, there will be sales. The new Copilot Plus PCs are out, but only those with plenty of money or the brave rush out to buy the latest models. Everybody else waits to see what, how it's all going to pan out.
That's Alex Zaharov-Reutt from Tech Advice Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.